Okay, here's us starting at the top of the list. If someone hands us the function 4x plus 7, how do we find the derivative? Pause the video for a second. Welcome back. What did you think the answer was? Well, this is a line. And when someone asks for the derivative, they're asking for the local slope. But for a line, the local slope and the slope are exactly the same thing. And so what we get here is just a slope. Those of you who know the power rule, no one wants to see you use the power rule here. We want to be able to recognize lines for lines and just say, hey, for lines, the derivative is just the same as the local slope. The next question on the list that take the derivative of is this one. Pause the video. Did you figure out what the answer is? Well, that is a line, but most people actually want us to look at that and say that's a constant function. Constant functions are horizontal lines, and horizontal lines have zero slope. And that's the way we want to be able to do constants. We don't want to use a power rule. We don't even want to call that a line. We want to say that's a constant function. Constant functions are horizontal. Horizontal lines have zero slope, and that'll make the derivative 0 for all that. Let's go to the next one. Now this one I'm not going to pause on because this is one of the 3 that are listed down the page that we actually did in class. I've done it in class, you've done it in class I think twice. And so this is just one of the ones I want to have memorized. It's just 1 over 2 root x. We earned that one by hard work and I want to make sure we use it. All right. The next one is the square root of 5x. Okay, pause the video, see what you would do, and come back. Welcome back. If I'm going to do that one, I'm going to say I don't know how to take the derivative of square root of 5x, but using our algebra, we know that we can rewrite this as the square root of 5 times the square root of x. Now, we can use our constant rule. We have a constant, well, it's called coefficient rule. This is a coefficient of this function. What we know, according to one of the rules, and we'll talk about this a lot, is if we want to take the derivative of a coefficient times a function, it's just the derivative of the function, and the coefficient just goes along for the ride. That's usually the way I like to phrase it. But we had to rewrite that to see that there was a coefficient. All right, I'm looking at the next one. Next one says 3 sine t. Pause the video for a second, see what you would do. Welcome back. What I see is a coefficient times sine. Remember, the coefficient goes along for the ride, and sine is one of our basic ones. This is just going to be cosine. And if you want to know why, watch the video. We go through it informally and formally. You could stop at the end of informal, at least understand why the derivative of sine would be cosine. Anyway, there's the derivative. Here we go. Looking at the next one, it's pi times e to the x. Okay, pause the video, see what you would think to take the derivative. Welcome back. When I see this, I see pi, which is a coefficient, times e to the x, which is one of our core ones. So the coefficient goes along for the ride, like this, and then the derivative of e to the x is just e to the x. If you want to see why, you should watch the video. We do an informal thing with the graph, and we do the magical thing that Euler did originally to come up with the derivative of e to the x. It's unbelievable what he thought, and it's very, very cool. All right, we're going to go on to the next one. The next one is 4x plus 7 plus square root 2 plus 3 sine t plus pi e to the x. All right, pause the video a second, see how you would do it. Welcome back. How am I going to do all this? Well, we should recognize that we've already taken the root of 4x plus 7 and the square root of 2 and 3 sine of t and pi e to the x. We're just adding them all together. Where there is a sum rule for derivatives, it's probably the easiest one. It says if you're adding together a bunch of functions whose derivatives you know, the derivative is just the sum of all those derivatives. So for example, we know that this derivative was just 4. The derivative of square root of 2 was just 0. The derivative of 3 sine t was 3 cosine t. And the derivative of pi e to the x was just pi e to the x. So using the sum rule is really, really easy. I don't like to go into it too much because most people get it right the first time. I'm just moving on to the next one on the list. The next one on the list, never should erase that, I guess, is 4x plus 7 plus square root 2 plus 3 sine t plus pi e to the x. I have to write it all the way over here because I wrote it as a giant fraction, all over 10. All right, I want you to pause it for a second and think about what you would do to try to find the derivative. Welcome back. We should recognize that we just took the derivative of the whole top, but it's over a 10. What am I supposed to do? This is a very, very common thing in calculus. Please do not forget it. Dividing by 10 is the same thing as multiplying by 1/10. So the very first thing I can do is I can pull out the 1/10 and say the 1/10 is just a coefficient. Coefficients go along for the ride. And so what I want to be able to do here is just put the derivative of everything else, which we just did, right? There should be 4 plus 0 plus 3 cosine t plus pi e to the x, and we're all done. Remember, you can pull constants out of tops, you can pull constants out of bottoms. We're going to need them both all semester long. All right. Now, using a rule that we haven't used yet, the next one on the list says they want to take the derivative of e to the x cosine x. I want you to take a minute, go down that list of basic rules that we have and see if you can see which rule to use and what you would do to find the derivative. Welcome back. This is a product, right? And we have a product rule. The answer to the derivative of a product rule is not the derivative of this times the derivative of this. It's much more complicated. What I usually like to do when I do these is try to map out the answer. I know that the derivative of a product is always something times something plus something times something. And I'm just going to start filling in stuff. The rule says it's going to be the derivative of the first times the second plus the derivative of the second times the first. And we're going to start filling stuff in. The derivative of the first is just e to the x. The second is just cosine. The derivative of the second is going to take a little bit of this. The derivative of cosine is minus sine. And if you want to know that, by the way, graph cosine and then just sketch the derivative of cosine yourself. You're going to find yourself drawing minus sine. It's the best possible explanation for why the derivative of cosine is minus sine. It's not a proof, but it's not bad. Anyways, there's the derivative of e to the x cosine x using the product rule. So it's something times something plus something times something. All right. Let's get rid of that. What's the next thing on our list? 2x sine x. This is a lot like the one we just did. Stop the video, try to take the derivative, and we'll compare answers. Welcome back. This is a product rule, so it's going to be the derivative of the first times the second, plus the derivative of the second, times the first. The derivative of 2x is 2. Why? Because 2x is a line, and for a line, derivative and slope mean the same thing. Derivative of the first, times the second, plus the derivative of the second. This is one of our core rules, that the derivative of sine is cosine, times the first. And we get that. Yay, the derivative of 2x sine x. That wasn't so bad. Looking at the next one. The next one on the list that they want us to do is 3 e to the x over 5x. Those of you who had some calculus, don't use the quotient rule. We're trying to get really fluent with all of the ones in the basic rules. And see if you can go up and down the list and see if you can't rewrite this somehow so we can use the rules we have. Pause the video, see what you can do. Welcome back. Now I warned there was going to be a little bit of rewriting, so let me rewrite first. I'm going to pull the 3/5 out, and then I'm going to rewrite the inside as 1 over x times e to the x. Now why would I do that? Well, for the following reason. Yes, coefficients go along for the ride. 1 over x is something I took the derivative of. You took the derivative of at least twice, right? And it's on our page. So what I'm going to do is use the product rule and the fact that we know the derivatives of each of these. So I'm going to get here, a 3/5 is a coefficient. It goes along for the ride. So let's see here. It's going to be the derivative of the first times the second plus the derivative of the second. Well, the derivative of e to the x is e to the x times the first. And we took the derivative of that without any fancy rules, using only the ones we have. That's going to be a constant theme here. All right, next one is a little more abstract, but more useful than any of the single examples we have so far. This says, what if I want to take the derivative of 3 things being multiplied together? Not particularly fond of that notation, but we'll use it. So what I want you to do is pause the video. This one might take a couple minutes, but it's really worth the effort. See if you can actually use the regular product rule and come up with the formula for the derivative of 3 things being multiplied together. Okay, welcome back. Now the problem with the product rule as it stands is that we have to take the derivative of just 2 things multiplied together. So this is what I'm going to do. I'm going to rewrite out of space here. The original, I'm not going to take the derivative yet. I'm just going to group this associative law, yes, the first 2 like that. And then I want the derivative. Now I can actually use our regular product rule. Boy, I don't like calling that f prime. Anyways, it's going to be the derivative of the first. Remember, that is the first, yes, times the second, plus the derivative of the second times the first. I mean, that is correct, but it's not very helpful because I still have the derivative of fg, but this is now the ordinary product rule. So I'm going to write that out. This is going to be f prime g, like I say, plus g prime f, like that, all times h, plus h prime, take away the parentheses at the moment, you get something like that. Still doesn't make a whole lot of sense, but let's rewrite it. I'm going to get f prime gh plus g prime fh plus h prime fg. Now what we're looking for is a pattern here, and I think this is a wonderful way to do this, and I'll try to defend my phraseology in the next one. This says when you're multiplying 3 things together and you want the derivative, ready? It's the derivative of the first times the other 2, plus the derivative of the second times the other 2, plus the derivative of the third times the other 2. And this is a pattern that actually extends. So let's look at the next thing we're going to be asked. The next thing we're asked is, they want 4 in a row, right? So let's see here. If the function given is 4 things being multiplied together, all they asked for here was to describe the derivative. So this should involve lots of words. It should involve the pattern we just did. So pause the video, talk it over with each other, and see if you can't come up with a nice way of describing the derivative of 4 things being multiplied together. Welcome back. If the pattern holds, what we should get is the derivative of the first times the other 3 plus the derivative of the second times the other 3 plus the derivative of the third times the other 3. I didn't do this right, did I? G prime FHL. Yeah, better. Plus the derivative of the last one times the other 3. Let's see, I'm not there yet. FGL plus L prime FGH. Did they all get there? We did, right? So it's the derivative of the first times the other 3, plus the derivative of the second times the other 3, plus the derivative of the third times the other 3, plus the derivative of the fourth times the other 3. This is a pattern that we're going to be using a lot. All right. The next one on the list says, if they give us the function 3x e to the x sine x, we want the derivative. Well, how am I supposed to do that? Hint, 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 hint. Those are 3 things being multiplied together. Pause the video, take a minute, it shouldn't take any longer than that, and write out the derivative of 3x e to the x sine x. Welcome back. This is 3 things being multiplied together. So it should be the derivative of the first, which is 3, times the other 2. Yeah, we can make that look like a 3, I think, if we try really hard. Right? There we go. 3. Yay. Times the other 2. Plus the derivative of the second. Derivative of e to the x is e to the x. If you want to see why at the moment, see the video. And see the miracle that Euler did when he actually took the derivative of that. Okay, derivative of the first times the other 2, derivative of the second times the other 2, derivative of the third times the other 2. Like that. And we get the derivative of 3 things being multiplied together, really without breaking a sweat, which is nice. All right. The next one in the example list looks like minus 7x squared. Let's see here, e to the x sine x cosine x. And we want the derivative of all that. Hint, 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 that's 4 things being multiplied together. Take a minute, it shouldn't take longer than a minute, and find the derivative. Welcome back. First thing I'm going to do is pull out the minus 7. I'll call this like this. I'm going to say minus 7. I know I'm adding up a lot of things. I'm just going to put giant brackets here. What's left? I have x squared e to the x sine x cosine x. So it should be the derivative of the first times the other 3, plus the derivative of the second times the other 3, plus the derivative of the third times the other 3, plus the derivative of the fourth times the other 3. The first thing here says the derivative of x squared. Well, how are we supposed to do that one? That's actually one on our list. That's something I took the derivative of. It's something you took the derivative of, and we earned it, and we get to use it. So anyways, it's going to be the derivative of the first times the other 3, e to the x sine x cosine x, yay, plus the derivative of the second, which is e to the x times the other 3, so that's x squared times sine x times cosine x plus the derivative of the third, which is cosine x times the other 3, so it's x squared sine, nope, didn't do that right, the other 3, e to the x cosine x, finally, plus the derivative of the fourth, which is minus sine x times the other 3, so it's going to be x squared, and then e to the x, and then sine x like that, and a big bracket like that. Whew. So we can take the derivative of 4 things being multiplied together, as long as we know the derivative of each of them. You're going to be using that a lot this semester, but not just with 4. Meanwhile, I'm looking at the next thing on the list. The next thing on the list is e to the 4x. Now, those of you who use the chain rule, we don't have the chain rule yet. Chain rule is actually a lot harder to explain. We can do this knowing just what we have today. So what I want you to do is take a minute, maybe 5, and ask yourself, how can I rewrite e to the 4x so I could possibly take the derivative? And then use the rules. Welcome back. What are we going to be using here to rewrite? We're going to be using rules of exponents because e to the 4x, I guess we can write it like this. We don't have to. Is e to the x to the 4th, like that, which is equal to e to the x times e to the x times e to the x times e to the x. Now, why in the world would I do that? That's 4 things being multiplied together. So if I want the derivative, it's going to be the first derivative of the first e to the x, yes, times the other 3 being multiplied together. Well, I'm just going to call that e to the 3x at the moment because that's what e to the x times e to the x times e to the x is. Now, what did I do? That's the derivative of the first times the other 3 plus the derivative of the second times the other 3 plus the derivative of the third times the other 3 plus the derivative of the fourth times the other 3, like this. I would like to simplify this. We will be using this as an example later on. What I'm really doing here is adding e to the 4x, because e to the x times e to the 3x, 4 different times. So it's this e to the 4x plus e to the 4x plus e to the 4x plus e to the 4x, and we get as an answer something that's not so bad, right? Ta-da! All we did was rewrite and use the product rule. Happy with that. Let's see here. Oh, we only have one thing left. I want the derivative of x to the 10th. Derivative of x to the 10th. So the function is here. Straighten this up a little bit. It's just x to the 10th. Those of you who know the power rule is the hardest one to explain, so don't use it. Try to mimic the last example we just did where we rewrite this as a product. And come back in a minute, and we'll show all the work we have to. So here we go. Welcome back. What I want to do, I want to rewrite this as x times x times x 10 times. There's going to be 10 x's written. Yes, 10. If I want the derivative, how am I supposed to do that? Use the pattern. The derivative of 10 things being multiplied together should be the derivative of the first times the other 9, plus the derivative of the second times the other 9, plus the derivative of the third times the other 9, plus the derivative of the fourth times the other 9, etc. Now here we go. The derivative of the first x is 1. Why? Because x is a linear function, and slopes and derivatives for linear functions mean the same thing. So it's going to be the derivative of the first x times the other 9 x's. Well, that's just going to be like that. So it's the derivative of the first x times the other x's, plus the derivative, the derivative of the second x is 1. All the other x's multiplied together, that's also x to the 9th. The derivative of the third x is 1, times all the other x's is 9. The derivative of the fourth x is 1. Here we go. I guess I'm going to write it all out. Times this, yes, that's the derivative of the fifth x, plus the derivative of the sixth x times the other 9, plus the derivative of the seventh x times the other 9, plus the derivative of the 8th x times the other 9 functions, plus the derivative of the 9th x, which is 1, times the other 9 functions, plus the derivative of the 10th times the other 9 functions. Whew. What am I supposed to do? Well, I'm adding up the same thing. How many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's actually our definition of multiplying. So what we're going to get, technically, is 10 times 1 times x to the 9th. We could probably leave off the 1, but strictly speaking, that's what we did. And what we get is 10x to the 9th. Those of you who have seen the power rule before, you still can't use it. It's a nice check, though. All right, we're finally done.